Hello. In this video I will explain how to automatically start programs running during the startup on a Raspberry Pi or other Linux computer. It will show you how you can start background services, graphical applications, and how you can start programs at certain times of the day. It will even include an example of how you can start a graphical game and play it with a games controller without having a screen attached. Spoiler alert, it's a game involving LEDs. So whilst it does have a graphical display, you can play it without seeing the screen. I'll be covering that later in the video, but you can skip to the relevant chapter if you want. So firstly, why would you want to start a program or application automatically? There are already dozens or even hundreds of programs or daemons that run on a computer. These could be keeping the time on your computer correct, handling print requests, receiving networking requests, handling the graphical interface, or even starting other programs to run at scheduled times. This is HTOP, which shows the top processes that are running and using the most resources. There's about 140 processes running on this system at the moment. If you enjoy physical making projects, then it's quite common to want them to start automatically. This may be so that they can start running a program without needing user interaction, or so that they can start a program ready for a user to interact with it. This guide will be based around systemd desktop files with autostart and cron tab. The examples are based around the Raspberry Pi OS, but most of the Linux distributions work with these methods. There are other ways of starting programs running automatically, but these are the ones that are generally well supported and based around the modern approach. With these techniques, you should be able to start any kind of program you need. I'll treat these as three different types of programs that you want to start up. Server daemons are programs that run in the background. These are often out of sight to the end user, but critical to the functioning of the system. I will show you how you can start these using systemd. Graphical applications, which could cover any kind of graphical application that you want running when your computer starts. It may include programs that run in the background but rely on the X Windows environment. These can be started using .desktop files placed in the autostart directory. And then I'm going to look at short run programs, things that you need to run regularly. These often do important system administration functions that run on a regular basis, but then close down until they need to be restarted. These can be started using cron tab. Cron tab is the odd one out here. You can actually achieve everything that the cron and the cron tab does by using systemd, but it's simple to use and still popular for certain system administration functions, so I will cover that. To demonstrate these, I'll be using some example projects, including my LED matrix display program, a snowman badge, and Christmas tree light automation. I'm going to start with the server code. I'll use my RGB matrix display as an example for this. This is a RGB matrix screen which is mounted outside my house. The finished version has a Raspberry Pi fully enclosed inside a picture frame, so it's not possible to connect a screen and keyboard without unmounting the whole setup. This actually uses two separate server daemons. One handles displaying the images on the display, and the other provides scheduling of different types of images and animations. These two daemons communicate through a common config file, which one daemon updates and the other daemon reads. From a system architecture point of view, there are other ways this could be achieved. Arguably, some would be better, but in this case, I wanted to have the programs able to run independently, and because they only need to communicate infrequently, typically a couple of times a day, then it works quite well for this. Anyway, this video is about the startup files rather than the system architecture, so let's move on. So the way these work is that the matrix display images program is a C program. This is responsible for updating the images on the screen. And in the case of an animation, that can mean displaying multiple frames per second. This was therefore created in C and has minimal functionality, so it can run quickly without putting too much load on the Raspberry Pi. The other is a Python program, which runs as a server daemon but spends most of its time sleeping. Whenever it wakes, it refreshes its own config file and sees if the date and/or time matches one of the special sequences. If it does, then it updates the display image.cfg file. So assume the day is now the 4th of May, which we all know is Star Wars Day, a day where we wish everyone May the 4th be with you. The Matrix Messages program updates the display image.cfg file to display a link to the Star Wars directory. Then the next time the matrix display images is ready to change to the next file, it sees the config has been changed and rereads the config file and then updates the display. The same thing can happen on other days, such as Halloween. So in this case, we have two different programs. They're designed to be semi-independent, so I created two separate systemd startup files. So we'll first look at the matrix display images service. This runs the C program to update the display. To register this with systemd, we first need a file ending with .service. This is stored in the /etc/systemd/system directory. The file is called matrix display images.service. This is a very basic service file using the minimal requirements. It's a plain text file with different sections titled using square brackets. The common configuration items are in the unit and install sections, and the service section has items specific to the service being started. The Unix section starts with description equals display images on an RGB matrix. This description is fairly obvious by its name. It's a user-readable string saying what the service does. The next line is after equals sshd.service. So the after instruction says to start this after a particular service is started. In this case, I put it so that it starts after the SSHD, the SSH service starts. For this particular service, it doesn't really need the SSHD service to be running first, but I didn't want this to delay the network setup due to the resources it's going to consume. So it works quite well for this to wait until after SSH is started first. If you have any other requirements, then there are different instructions which can be used, such as before, which ensures that this starts before another service, or requires, which creates a stronger requirement dependency. The after instruction is sufficient here. The service section has details of the programs to start. The exec start is used for the command that gets executed. You should enter the full path of the executable file. You cannot assume that it will be in your home directory. In fact, the systemd daemon will be running as root and not under your username. Which brings us nicely to the next instruction, which defines the user that the service should run under. In this case, the executable needs root permissions to be able to talk to the hardware. But if you don't need administrator permissions, then you should normally use a less privileged user. The final section is the install section. It has the wanted by entry, which is used to ensure that this starts whenever the computer starts in a normal user level mode. Using the multi-user target means that this will start before the GUI, and in fact will start even if the GUI isn't going to start, such as if you're running in headless mode that this particular setup uses. Now we've got the systemd service file, we can use that to set the service to automatically start. First we need to change it so it's owned by root and it's executable. So the chown, change owner, and chmod to change the permissions so that that can run. At this point, it's a good idea to test the script rather than waiting for a reboot. So this is done using sudo systemctl start and then the name of the service. And you can run the same but with the status command to check that it's running. You notice I'm using the systemctl, system control command here. You can also use the service command, but systemctl is specifically for the systemd system, and it's good to be using that rather than the old service command. You can now enable startup at boot using the systemctl enable command. And once you've done that, then it will allow it to run at boot. And this shows the status command showing that it's working. And then the other aspect is the matrix messages. So this is another example using a .service file. And this is for the Python program, which runs alongside the matrix display images code. Similar to the previous example, but designed to run as a normal Py user, not root. And you'll also see I've included type equals simple in the service section. That's the default, so it's not really needed. But what this means is that the program will be considered to have started once the main program is running. This is used when your program runs as a single process, whereas some server programs will fork by splitting into multiple threads so they can handle multiple requests simultaneously. There are lots of other commands that can be used in a .service file, depending upon how the program will be started, what its dependencies are, and what the system should do if it doesn't start correctly, or if it crashes, say, then it can try and restart it. So there are lots of other reasons why you might want to use systemd to start a program. These are a few of the examples that I've used it for. So using robots, when I've been providing, say, a web interface to them, running web servers, my model railway automation project, and if you want remote access using tight VNC, then that's one way of providing that as well. So next we're going to look at how to start an application once X Windows is started. This can be useful if you want a graphical application running, such as one written in pygame or pygame 0, or if you want to be able to use a joypad, such as qjoypad, which I'll be covering in here. This guide is based around LXDE, which is the environment used in the Raspberry Pi OS image, but it's similar for other desktop environments. This also assumes you have auto login enabled, otherwise it will start when you actually log in rather than when the system boots. So I'll be showing two examples here. The first is the Chromium web browser. You can follow along this one even if you don't have any of the additional hardware for the second example. And the second example is based around a maker project, in this case a snowman badge, which runs as a graphical program, but I wanted to run it without a screen and interacting with a joypad games controller. This works by creating desktop files. These are useful files as they're used by the system for any kind of custom launcher and if you want to put a menu item on the start menu. So it's useful to understand these even if you don't need this program to start automatically. And so just be aware that some of the options that are in these won't be necessary for the auto start. You can use a more stripped down version if you want. On here you can see a Raspberry Pi system looking in the user/share/applications directory. And this is where the system uses to hold the desktop files. When you're in the File Explorer, it shows these as icons, but you can actually see they're actually text files. And if you right click, you can open it as a text into a text editor to actually see what they look like. So we're going to have a look at how you can start the Chromium web browser each time the system starts. You can find the existing desktop file for the Chromium browser in the user/share/applications folder we were just looking at. You can open that in the text editor and see how this works. But this file is 295 lines long. So we can strip it down. First, as you can see here, there's lots of additional entries for different languages. Whilst these can obviously be useful for those that don't speak English, they make the file look very complicated. So I started by removing those entries. And this needs to be done for the section's name, generic name, and the comments. I'm also going to remove anything from the line desktop action, new window and below. Those are commands that can be useful when launching from the start menu, but they're not relevant for the auto start. So this is my stripped down minimal version of the Chromium desktop file. So as you can see, it starts with the desktop entry and a version number. Note that the version number here is the specification for the desktop entry. It's nothing to do with the version of the web browser that you've got installed. The name, generic name and comment sections are all user readable strings. They're used for things like hover tips, etc. The exec entry says what should be executed. Here it says the Chromium browser and it's got %u. The first part is the name of the executable to run, and this just uses the name Chromium browser. There's no path, so the command needs to be in the search path. In this case it's in /usr/bin. If you're running your own program which is not in the search path, then you should include the full path to the executable. The %u is how URLs can be sent to the browser for it to open those directly. Using a capital letter U means that each of the entries, URLs in this case, are sent as a separate argument. Terminal equals false is used because this is a graphical application. If you wanted to start a command line program in a terminal shell, then you could just leave this as true here. I'm not sure about this next line, the x multiple args. It appears to be an extension of the original specification, so it's not listed in the official documentation for the desktop file. Presumably it's something to do with how multiple arguments are sent to the browser executable, so it's not going to be important for auto start, but I've just left that in. A type equals application defines this as an executable file. And then it has an icon, which is for, you guessed it, the icon to display. The icons are in the /usr/share/icons directory, but there are other directories under there. In the case of Chromium, it's within the high color directory, with different sized icons depending upon the size that the icon is to be displayed on the desktop. Categories defines what categories it's listed under. For example, which submenu it would be added to if it was going on the start menu. The MIME type determines which files types the program should open automatically. Startup notification parameter is used when the desktop environment supports startup notification. For example, in other desktop environments such as GNOME, then it can be used to stack the application icon on top of the pinned application. The actions parameter is used to add alternative options on the start menu. This is not supported in LXDE anyway. And then finally, the XApp install app package is another extension to the specification. It's used to indicate how the program installed or uninstalled. So we've got the desktop file, but what can we do with it? You can launch the application directly from the applications directory. In some desktop environments, then that will be available through the launcher once you've created this file. You can use that to add an entry to the start menu, the taskbar, or the desktop. And the reason we're looking at this here is because we want to start a program automatically. So, and the directory to store this under is /home/py/ .config/autostart. The directory may not exist, in which case you'll need to create that directory first. So save a copy of this file into the autostart directory and reboot, and you should see that the Chromium browser starts up automatically. You can also change that file. I've already created the desktop file in my autostart folder. I'm going to make some changes. For example, I want my browser to start in kiosk mode and to a certain website. So I'm going to change the exec command, add in the parameters no dialogues to disable error messages, disable info bars to disable the information bars, kiosk mode, and then I'm going to put the URL of my website www.penguintutor.com. Note that this is not enough to use this as a proper secure kiosk. There are other things in the operating system you should disable as well. You'll probably want to start with a minimal operating system, but it does provide a way you can auto-start the web browser in the console mode. So I'll now restart the system, and we should see that it starts up with the browser in kiosk mode. I'm now rebooting, and I'm capturing the full display as this happens, so you should be able to see it start directly into the browser. Another example is where you've created a program to interface to an electronics project. In this example, the program is a graphical interface I created to interact with a snowman badge, which I used to create a game. The graphical game was created using pygame 0, as that provides the interactivity I needed. I then used qjoypad, which provides a way of passing joypad controls to the graphical interface. This was incorporated into a badge as part of a charity event. I wasn't able to carry a computer screen with me, so the Raspberry Pi was run headless. I therefore needed a way to start both qjoypad and the program in a graphical environment, but without a screen and keyboard. If the program needs to be able to access through the GUI, such as using pygame or pygame 0, then this needs to be started through the autostart directory. The same technique has been used in some of my Raspberry Pi robotics projects, where I've used qjoypad to interact with a terminal application, which is started automatically. Links to all these projects are included in the video description. You won't necessarily have a desktop file already, so I'm going to start by showing you how you can create a very basic startup file that can be used. The Snowman code and qjoypad need to be set up first. The code for this is on GitHub, so if you want to follow along, then you can install this from here. The first thing is that I've already created a script which can be used to start both qjoypad and the Snowman program. This is located in the GitHub for the Raspberry Pi Snowman badge. The script is called snowman.sh. The code first changes to the appropriate directory using cd. Then it launches qjoypad with the Snowman keyboard setup, and then uses pgz run, which is pygame 0, to run the snowman.py file. This script needs to have executable permissions, and then it can be called from either the start menu or auto start. The reason for running it through this script is that I always want qjoypad running whenever I start the game. Although it can be played from the keyboard, it's really designed to be used with the joypad game controller. Therefore, this can be added to the start menu, and it will always launch qjoypad. When using it through autostart, then you can create two separate autostart files. But as I'd already created this script, I think it made better sense just to have this as a single desktop file. So this is the desktop file used to launch this. It's a very basic desktop file. I've really only put a few lines in here. And all these are things that we've already come across in the Chromium desktop file. You can save this in /home/pi.config/autostart/snowman.desktop, and then it will start automatically whenever the computer is restarted. And the same technique can be used for other programs that need qjoypad, such as the Raspberry Pi robots that I've made. As you can see, the game launches, and qjoypad is also running. There is a slight issue with this in that if qjoypad starts before the LX panel, then the icon may not appear on the panel. This will depend upon how quickly your computer starts up. qjoypad is still running and working, but it's not possible to update the config file. A workaround for this is to add sleep 5 in the snowman.sh file before qjoypad. So we can try that and restart. As you can see, the qjoypad icon is present this time. The final method I want to talk about is cron tab. Actually, it's cron rather than cron tab, but I'll explain that in a while. So this is a bit different in that I'm going to look at how this can be used for scheduling events at regular intervals rather than running from startup. You can set programs to start when the system starts through cron, but in that case you're probably better off using systemd. You can also do everything that cron does directly in systemd and forget about cron. But what cron does is provide an easy way to schedule programs, and for that reason it's worth covering. I won't be going into full details of how to use cron. That could include a video on itself, but I'll give an example of where you might want to use it. To do that, I'm going to use another Christmas theme program, which is my Christmas tree light automation. This project doesn't have to be related to Christmas at all. It's just a way of turning mains electrical devices on safely. It can be used in various home automation projects. So cron tab is actually the name of the program used to interact with cron, but really it's cron that does the important work. Cron is the system daemon that runs on the system. It reads the values from the cron tables. But updating cron and editing the cron tables is done through the program cron tab. So you may hear people using cron or cron tab interchangeably. But I just wanted to make that distinction clear here. When we're editing cron tab, that's the program edits the tables, and then cron is the program that runs and launches the programs when it's appropriate. So as I say, the example here I'm going to use is based around my Pi Power project. It's a web-based application that provides a way to turn electrical sockets on and off through a web interface. You just press the appropriate button for whether you want to turn the socket on or off, and it communicates through the Energini Pi mode. This runs automatically, and in fact the program is started using a systemd.service file, just like the examples we saw previously. The thing I wanted to do is have it automatically turn certain sockets on and off at preset times. In the case of the Christmas tree, it meant that lights could be switched on before I came down in the morning. It can also be used as a useful burglar deterrent, making it appear the home is occupied by turning lights on and off automatically. Because the Pi Power application provides a web-based interface, it's possible to trigger the sockets on and off using a command line web query tool, wget. The first command is to turn the socket on. Then you need to access the link with switch on with the socket number. And then to turn it off again, use the same but with the switch off command. To edit the cron tables, then use the command crontab -e, and this will create or edit the cron tables for the current user. You may be asked to choose your preferred editor when you first launch this. I'm using Vi, but beginners may prefer the Nano editor as it's easy to get started with. There are lots of comments put at the top of this, but the most important is this last comment entry, which has a lowercase m, a h, and then all the other examples there. The M means that the first field should be the minutes. The H is for hours, DOM is for days of the month, MON is for month, and day of the week is DOW. The fields can have a single value, a range of values, or an asterisk, which means every occurrence. And you can see examples of all of those in these commands. The first entry, shown here, means run the command whenever the minutes are on 0, so on the hour, whenever the hour is 8, so 8 o'clock in the morning, on any day of the month, any month of the year, but only on days 6 to 7, which are the weekend. The rest of the line is the command, which uses wget. It's also got the option -o/dev/null. That means to ignore the output. It's to discard basically the value we get back. And then it's got the command which turns the socket on, which is what's doing the job. So whilst cron may seem a bit cryptic at first, it's a quick and easy way to schedule jobs. And it's worth looking into if you're interested in doing that. So in summary, we've covered 3 main methods which should cover most scenarios where you want to run a command on startup or schedule at a specific time. There are other alternatives. For instance, the at command can be used as a one-off alternative to cron. And it's also possible to use the older init.d files or rc.local. But in most cases, systemd, the desktop autostart folder and crontab should meet your needs. I've only briefly covered the commands in this video. If you want more information on all these, then see the links in the description. I hope this has been useful. Please give it a thumbs up if you learnt something new, and please consider subscribing to my site for future updates. I look forward to seeing you on a future video.